So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveli Talent Schools and the Mastermind Schools. So once again, I welcome all the class 9 students of KTS Jogipet and other Krishnaveli Talent School, which branch, for today's session. As you all can see on the screen, and you are well aware. So my subject is physics. We are in class 9. Today we are going to start a new chapter, work, energy and power. And today is the session number 1. So already we learned this chapter in the lower classes, that is in 7th and if some part in 6th. But mainly there are three terms are there. Term number 1, work. Term number 2, energy, and 3 is the power. Even though there are 3 different terms, but one is connected to another. All 3 are connected with each other. So they are not independent. One is dependent on other. That's why they are given combinedly. And this combination of these 3 words will lead for the very big branch of physics with more and more even theorems also there, which is connected to them. Work energy theorem and law of conservation of energy. So many laws and theorems will come based on the only 3 terms. So they are simple terms, but they are powerful terms which are even applicable in our day-to-day life. We will commonly use the word work. What work we will do from the morning? What is the energy required by you? We work on energy also. We'll take some food to gain energy and we'll spend some energy for doing work. And we require power some cases. We have to apply more and more power. To apply more power, more energy is required. We have to do more work. So all the 3 terms of work, energy, power are interrelated and they are very much applicable in our day-to-day life. Right? Hope you all agree. Correct? Then we'll move to the chapter. That is, you can see the page number 114 of your material, where we can see about the work, energy and power. So just before going for the work, what is work, what are the types of works, some introduction part is given to understand what is work. So work is said to be done only when the force is applied on a body and makes body to move. Very important. So there are 2 terms will come for work. One is force, other is motion. Suppose when you are, say, a diagram is given there, the car is stopped in the middle of the road due to some problem, due to some self-start is not working. Then what you have to do? A person should get down from the bus and they have to apply force. When apply force, if the car will change the position, then you can say work is done. Even though it's applying the force, the car is not moving. We cannot say work is done. There should be force and there should be motion or displacement. Then only you can say, for example, your table is there. So you want to move because you are not able to sit comfortably on table. So what you will do during break time? You will move the table towards some other direction. You can move easily, you and your friends together. But suppose your class is very tight. So there are 40 students are there in a small room. It is very congested. So what you and your friends always thought, we'll move the wall. You may want to make the room big. And you are applying force on the wall. Can wall is move? No, it won't move. But still you are applying force. All your 40 students are applying force on a wall. But you cannot able to move the wall. So there is no work. You can say there is no work done. Even though your wave force is wasted, as the body is not displacing, we cannot say there is no work is done. As long as body displaces along the direction of force, the work is said to be done. Right? Understood? So some more explanation. In our daily parlance, the word work is used for some sort of exertions, that is physical or mental, right? Or for various activities such as writing, reading, eating, we say we are doing work. Or for, however, in physics, the work done is used in a specific sense. We are saying you feel that by sitting and reading, you feel that I am doing a lot of work, or by washing the clothes, your parents are saying a lot of work they are doing, washing the utensils, and daily going by car and coming also, you feel you are doing some work. That is a general work in our day-to-day life. But in physics, there is some sense is there. A work with some specific senses, there should be a displacement. So work is said to be done only when body moves under the influence of force. In case of physics, only the work is said to be done when body moves. Right? So if there is no displacement of the body, even when the force acts on it, no work is said to be done. Or the work done is zero. Thus, for example, a man while pushing the car, a cyclist while pedaling the cycle, a horse while pulling the cart, a boy going upstairs, a coolie lifting a load, all exerts force that produces the motion, so they are doing work. All these examples you can see, so many are given. A man while pushing the car, one case. Then a cyclist while pedaling a cycle. A horse pulling a cart. A boy going upstairs. A coolie lifting the load. All these are the examples of the work done even in physics also. Right? So we'll see more examples and more explanation about this. So the term work and energy are frequently used in everyday language. A farmer clearing weeds in his field is said to be work. The work is hard to remove the. A woman carrying water from a well to her houses is said to be working. In a drought-affected region where there is no water, rain, she may be required to carry over large distances. If she can do so, she is said to be a large stamina or energy. So energy is thus the capacity of do work. Suppose in drought area where there is no water, some movies you can see, or maybe some villages can find, they have to carry water from long distance. So they are calling from 1 kilometer, 2 kilometers to their houses. So what we can say? Their work is done as well as their capacity also more for the lady or woman. That is called energy. Doing the work from long time, or the capacity or ability to do work. Right? In terms of power, usually associated with the speed. How speed you are doing work is power. Some work is given to you. 3-4 of your friends. For example, you are in study hour. Same target given for all the students in a class. Suppose they given 4 problems. So they started the doing problems, preparation. So one person will complete all the 4 problems in a study hour. One completed only 3. One completed only 2. One completed only 1. In same time. It's time of 30 to 40 minutes. So what we can say? The person who completed all the 4 problems has more power because he has done this all the 4 problems in some time. Maybe everybody of you know the all 4 problems, but you are not time sufficient. Give an exam also. How fast you are doing the work is called power. See, work, energy, power. Work, the body displaces. Energy is how much capacity you have to do the work. The power is how fast you do the work. Clear? Right? That is the interrelated, all the 3 terms, work, power and energy. Clear? This is just basic introduction about this chapter. Now we move to the one. We'll discuss in deep about what is work exactly, what is the energy, and what is the power and their types. Okay? So come to work done. Already we discussed. So work is said to be done when a force applied on a body displaces the body through a certain distance in the direction of force. Either it is you pull the table or push the table or pull the door or push the door. All these things makes the work to do. You're applying force on a door to open. If you apply the force, door opens, the work is done. If door is not opened, no work is done. No matter you are applying force also. Clear? Very good. So work done by the contact force. Let a constant force applied on a body such that it makes an angle theta. Second case it is. Generally work is done by W is equal to F into S. Force into displacement. But when there is angle is there, for example, you are applying force in some direction like this, force, the body displaces in this direction. Suppose say displacement. This is called angle. So when it is possible, for example, when you go to the gardens, there is a long roller. They'll always, even in cricket also, when pitch is always rolled with the rollers. So what they'll do, they hold the handle like this and they roll the pitches. They are applying force in downward direction, but the roller is moving along the ground. So there is some angle between the force and displacement. Correct or not? So then in that case, the work done is given by F into S cos theta. Right? Because horizontal motion is there. That is horizontal component we have to calculate cos. There is no effect of vertical component of force. We are applying the force vertically, but body is moving in the horizontal direction. In such case, the work done is given by F into S cos theta, Fs cos theta. Right? That is the one case, one special case. In physics, not in general life. That example we'll see next. Right? So, whenever a force applied and direction of displacement are in same direction, there is no matter, we'll get the F into S only. Right? This is the formula, common formula. But in case the direction of application of force makes an angle theta with the direction of displacement, in such case, that is given by Fs cos theta. So later we discuss so many examples also for both cases, right? So that is the two formulas for the work done, right? So there are some explanations, some one colorful explanation. Some examples are given to make you attracted. See, we all have concept of work, but in physics, the definition is very precise. We say that work is done when a force of F moves a body through a distance d. Right? Work is defined as force times distance. Force times distance, force into distance. So it is almost too painful to watch. See here. How they are rolling, rotating, carrying. A person is carrying the load of two-wheeler cart. So this is work done. He is pulling and the work is done because the direction of driving is same. Second case I told you, the force is applied this direction, body moving in this direction, making some angle theta. So first case it is W is equal to F into S or D. Anything you can use. D or distance, sometimes they use D. In second case, W is equal to F into S cos theta. That is, W is equal to F into D first case. In this definition, only the force is in the direction of motion. Right? If I pull the wagon at the angle, when you are moving some angle, it will change as a F into S cos theta. So clearly explanation is given in both cases. Right? So there are some, when you see the table here, it shows the units for both. So absolute unit, that is commonly units, and when there is a gravitational force comes into play, the units are called gravitational units. Like absolute units of work as well as gravitational units of work. So absolute units is joule. So work is measured in joule because W is equal to F into S. Either you can measure in Newton per Newton meter, or we can measure in dyne centimeter, or commonly joule. Joule is Newton meter, dyne is erg, CGS. They are called absolute units given here. 1 joule is equal to 1 Newton meter, 1 erg is equal to 1 dyne centimeter. So there are some relation also given. 1 joule is equal to 10 power 7 dyne. Okay. So some relations are there. When you come to gravitational unit, it is measured in kg meter or gram centimeter. Kg meter. So 1 kg meter is equal to 9.81 joule. 1 gram centimeter is equal to 981 erg. We can convert into joule or erg also. So whenever gravitational force comes into act to do a work, suppose we are lifting the weight from the ground to a certain height. So ground some book, some bag is there. You want to lift to your table. So what happens when you are lifting the bag? The gravitational force try to pull your bag downward direction. There means that is a gravitation. Overcoming the gravitational force, you have to apply the force to keep the bag into your table. Generally, you won't care like that. Like that, only you take the bag and keep. But there also work is done against the gravitational force. In such cases, we'll measuring units are either kg meter or gram centimeter, which is equal to 9.8 joule or 980 erg in case of CGS. So these are the units of work done. Normal units as well as gravitational units whenever gravitational force comes into play. Correct? Now, we'll see what are the types of works. Right? Let me close only. Types of works. So there are 3 types are possible with examples given. One is zero work, one is positive work, one is negative work. All the examples we can come across in our day-to-day life. Okay. So first see, type of work. First one is zero work. When theta is 90 degrees, why W is equal to F into S cos theta is a formula. So theta is 90 degrees means cos 90. Cos 90 value is 0. When this becomes 0, total work done becomes 0. Best example I'll give it. So Fs cos theta, cos 90 is equal to 0. So total becomes 0. So work done by a force is 0 if force applied on a body is in the direction of perpendicular to the direction of displacement. For example, simple example, see here. This fellow, the coolie, railway coolie or bus stand coolie, he is carrying your luggage on head. Right? So his force is acting in downward direction. He is moving in the horizontal direction on platform. So 90 degrees. So as per physics, not normally, this person not done any work because the force is acting in downward direction and is moving in the horizontal direction, perpendicularly or normally. The work done is 0 in that case. So don't argue with your coolie when you go to the railway station or bus station. Generally, luggage is moved. What we'll do? We'll hire one coolie. He will carry everything on his head and he'll travel. So you put it in your train compartment safely. Then when you ask for money, don't say that as per physics, your work is physics. Our regular is different from our physics point of view. As per physics, the work done is 0. So don't tell my name so that they'll arrest me. Right? My physics are told that the work done by 0 when you are carrying such luggage, and don't show my video. It is as per physics, this is 0, but not regular way. Okay. So how importantly the physics is applicable in our day-to-day life. Clear? So here. So what examples you can see here? Example 1. Consider a body sliding over smooth horizontal surface, a polished surface. The work done by a force of gravity and the reaction of the surface will be 0. This is because body force of gravity and reaction acts normally to the perpendicular distance. The same argument can be applied for a man carrying a load on his head walking on a railway platform. Both cases, the work done is zero only. When a body moves in a circle, right, and the work done by the centrifugal force is always zero. When body is keeping on circle, it came from starting from here to here again, same place after one circle. So what is the work done? Zero, because displacement is zero. There is no, so distance covered is maybe 2 pi r as per the circumference of circle, but displacement is zero. When displacement is zero, what happened? So W is equal to F into S. S is zero means automatically the work done also zero. Or in a circular path, the body makes one complete circle, the work done is zero. And the tension in the string of a simple pendulum is always perpendicular to the displacement. So work done is, tension is zero. Suppose like this. So it's a pendulum. So we are moving, pendulum is moving here and there. So here also same thing, because the displacement is perpendicular. So work done is zero. Right? If there is no displacement also, the work done is zero. Suppose you see the big stone is shown there. Very big stone. We are trying to push the stone. When you are trying to push the stone, stone is not moving. Even though you are applying the force, stone is not moving. So you can say work done is zero. Right? See here. There are some examples are given. Where some more. When a person tries to displace a wall or heavy stone by applying the force, then it does not move. The work done is zero. Just now I told. When you apply force on the walls of your classroom. A weightlifter does not work in a lifting the weight of the ground, but does no work is holding it up. If there is no force on the body, F is zero also, work is zero. Means when displacement is zero, work is zero. When force is not applying, work is zero. When angle is 90 degrees, work is zero. These are the three cases where you can see the work done is zero or zero work. It's called zero work. Clear? Now, the second one. Positive work. Right? Positive. So, second type of work is positive work. So, when theta is either greater than or equal to 0 or greater than 90 or less than 0, this comes under positive only. Therefore, W is equal to Fs cos theta is positive. Work done by a force is said to be positive if applied force component in a direction of displacement. Either pulling the table or pushing the table, or suppose you are sitting on a dining table, you want to pull some curry or chutney or curd towards yourself, or you want to pass to some other person. All these cases, we can see the positive work. Right? You can see some examples are given for positive work. When a horse pulls the cart, or bullock cart or horse cart, so they are pulling. Whichever direction horse is pulling, same direction body is displacing. Then applied force and displacement are in the same direction. So work done is positive. When a load is lifted, lifting force and displacement, suppose you are lifting the load from ground. So lifting force is upward direction and body also moving in upward direction. So that is also comes under a positive work done. When spring is stretched, both stretching force and displacement acts in a same direction. Some attached weight attached spring, stretching and displacement. Wherever direction force spring is stretching, in same direction displacement will happen. So these are the example for the positive work done. Means if the force applied and displacement is same direction, then body is said to be the work is said to be a positive. Clear? Then last type of work is nothing but negative work done. So whenever you can see condition is given, right? Work done by a force is said to be a negative if the applied force has component in the direct opposite to the displacement. You are applying force in one direction, body is displacing other direction. Maybe any direction, maybe 90 degrees or 40 degrees. lawn roller. Lawn, when you are cutting the grass in gardens, maybe some of your houses you use the lawn roller or grass cutter. Would apply force in some direction, but roller moves in other direction. So whenever the force and displacement are in opposite direction, the work is said to be negative. So the brakes are applied to the moving vehicle. The work done by the brakes or force is negative. This because the brake force and displacement acts in a opposite direction. When a body is dragged along the rough surface, the work done by the frictional force is negative because frictional force acts in opposite to the direction of force. When a body is lifted, the work done by the gravitational force is negative because gravitational force acts in downward direction, the body is going in upward direction. Right? All these are the example for the negative work. So, what we have seen, there are three types of work done are possible. One is positive work, one is negative work, and third one is zero work. Right? So, before going for the further explanation about the work and some more is there, just let me show you one video on the work done. Right? Work done and various types of works. Right? Come on.
Work and Energy. Part 1. Scientific concept of work. In this video, we will get an introduction to the scientific concept of work. Imagine you just completed your homework for the day and suddenly you hear someone say that you have not done any work. The term work has different meanings in our daily life and in science. What exactly do you think work is? Let's discuss some instances which we think of as work, but science considers it as work not done. You try to push a car, but the car does not move an inch. You might say that you have worked hard to displace the car, but according to science, no work is done here. Now, suppose you are rowing a boat or you are swimming in a river. In these cases, both you and science would consider it as work done.
So all
In
of the
our
negative
daily
works for the
life,
action
we
reaction.
consider both mental and physical effort as work. But science defines work quite differently.
Right? We feel that mental work also work only, but science is
Earlier,
different.
we looked at a lot of activities that we consider as work in our daily life. Now, can you answer a few questions about those activities?
So pushing the car, swimming, and working.
Who is doing the work? What is the work being done on? What is happening to the object? Now, let's have a look at a situation that science considers as work.
As
You
per
kick a
science.
football. Your work is done as you are applying force on the ball and it is being displaced. In this situation, there are two conditions that need to be fulfilled for the work to be done. 1. There should be a force acting on the object. 2. The object must be displaced.
Mandatory those two.
If any of the two conditions are not met, work is not considered to be done according to science. Now, can you think of some situations from your daily life where work can be considered done according to science? Let us perform a simple activity and derive the mathematical formulae for work done. In this activity, we will consider the force acting on the object is in the direction of displacement of the object. Take a wooden block and place it on a table. Let a constant force F be applied on the wooden block. Let the wooden block displace through a distance S in the direction of force. Let the work done here be W. Here work done W is equal to force multiplied by displacement, which is equal to F multiplied by S. Therefore, work done on an object is equal to the magnitude of the force multiplied by the distance moved in the direction of force. Work has only magnitude and no direction.
The scalar quantity.
The SI unit of work is Newton meter, which is called joule. What do you think would be the total amount of work done when force applied is 0 or when the displacement of the object is 0?
That done is 0.
Do you think
multiplied
work
by
done
anything.
is always positive, or is there something like negative work? Now let us consider some examples to see if the work done is always positive or not. Imagine there is a wooden block kept horizontally on a table and a string is attached to the block. Here, the displacement of the block is along the direction of the force applied. Now, we pull the string. The work done in this case would be force multiplied by displacement. In this situation, work done is positive.
The same direction is moving.
Suppose a car is moving from left to right with a uniform velocity. Now, we apply a retarding force in the opposite direction, that is, from right to left. There is a 180-degree angle between the direction of motion and the direction of force. In this situation, the work done is considered as negative. The work done may be F multiplied by minus S or minus F multiplied by S. Therefore, we can say work done can be negative or positive. Work done can be negative when the force acts opposite to the direction of displacement.
That is frictional force.
And work done can be positive when the force acts along the direction of displacement. Now, take a look at this coolie carrying
this
luggage.
0. Best
What
example.
do you think is the amount of work done by him against gravity? Here, the force acts perpendicular to the direction of displacement. In such cases, the work done is 0.
As per physics, not general.
In this video, we got an introduction to the scientific...
So all the three kinds of work done is explained here clearly, right? So what is work done? What is the positive work done? What is the negative work done given, right? So what we learn? What is the work done? And of course, how energy is connected and how is the power. The introduction is given. Then there are three types of work done: positive, negative, or 0. Clear? So when you meet next class, we'll continue the some theorem of work done followed by energy and power, right? Clear, all of you? So that's all for today. Thank you all the students. Thank you. Have a wonderful day.